I look forward to talking a little bit further about this question that you left off on in terms of what can we do to look at exposure and vulnerability. So my name is Erin and I work for the Red Crescent Climate Centre. So we are a small reference center within the Red Cross, Red Crescent movement, and we support national Red Cross or Red Crescent societies to try to anticipate climate-related risks. So this could be at the short term using flood modeling, it could be in the longer term looking at seasonal forecasts or climate change, and take action to anticipate these risks and reduce disasters before they happen. So we specifically try to target this question of exposure and vulnerability by understanding hazards. So you can imagine that this is just a quick look. If Google provides this service, just looking at the frequency of phrases in published books, and you can see that we are talking about and we are innovating as a scientific community in early warning systems, seasonal forecasts, hydrological models. We're looking at flood risk, and we have this information. And so my talk today is really about how the humanitarian sector underutilizes the information that you are presenting here, and how can we start to take action and systematically make better use of the risk information that's out there. So there are a number of different reasons why, flood models show peaks in projected discharge and nobody in the Red Cross pays any attention. And one of those reasons is because people really have a hard time understanding when do you take humanitarian action. So this is the question I get. If I talk about there are these great forecasts out there, there's really interesting models, people say, well, yeah, okay, but so then what should I do and when should I do it? This is the bridge that we're looking to cross. So a good example of this is in 2011. So this is drought, in fact, but there were, it's a nice example because it was a slow onset disaster. And there was just warning after warning, forecasted rainfall, observed, deteriorating conditions in these regions. And in the region, we received this information and we had meetings after meetings to try to decide what should we do, what's worth doing based on this information. And in the end, this was the first time that famine was declared in East Africa since the 80s. And this was a really terrible failure on the part of the humanitarian movement to act in advance of the famine that happened in Somalia. And so this is something that we would like to prevent from happening in the future, given all this early warning information that we have. One of the other problems in this particular case and in others is that we don't have humanitarian financing until, in fact, there is suffering. So you can see here, the black line is cumulative financing for this crisis in Somalia. And it wasn't until the last red line, so each of the red lines represents a different piece of information that should have given us an opportunity to take action. And it wasn't until famine was declared that we did in fact see that spike in funding. So at the Climate Center, what we're doing is trying to change this through something we're calling forecast-based financing. So the concept is actually quite straightforward. In advance, we will define what we're calling standard operating procedures that will define a threshold level of a forecast, both the magnitude and the probability, and link it with a specific action. So everyone agrees ahead of time, no one needs to take the blame in real time, but we've all said, okay, this particular forecast magnitude merits evacuating, for example, or doing something else, and we are going to put money in a specific fund that is available to be triggered based on this forecast information. So that's what's particularly new about this, is that we do have some pilot financing, which is the first of its kind within the humanitarian movement that is specifically tied to these forecasts. So we're piloting this right now in Uganda and Togo, and I'll be able to show you some preliminary discussions that we've had about how to create these standard operating procedures and how to make this link between the hazard information that we're receiving and the type of action that we can take on the ground. So making that link, however, is not as obvious as it would seem. You can imagine that this is a word cloud of a traditional chapter on forecast verification statistics. So this is what scientists are talking about. Here's another, this is a word cloud of a paper that was published on flood modeling, ideally to cause action by humanitarian people, presumably. But looking at using data to anticipate floods in Kenya. And this is a word cloud of Uganda Red Cross documents that have to do with floods. These are our post-disaster response documents. And so you can see that there really is very little overlap. The stuff that we're talking about, is what should we be distributing, who's affected, where is it water, is it health? And so answering these questions is part of our responsibility to try to make that link between the response and the flooding information that we're seeing coming out of the scientific community. So what are the forecasts that I'm talking about? This might be a question that you have as you listen to this. And the answer really is that we're quite open. We're happy to take action at all time scales. So what we'd really like is to see an integrated system, starting from seasonal level. We could take some preparatory actions, take different preparatory actions based on forecasted river levels, forecasted rainfall, observed rainfall, upstream river levels. All of these things will give us a different amount of lead time, but we should ideally be able to integrate them into a system where we take action when the alert is high enough, and we've calibrated this ahead of time. So in Uganda, there are a couple different actions that people are talking about doing with this new forecast-based financing. So I'll take you through two of them right now. One of them is to dig trenches, and so this is something that's fairly low regrets. It's something that happens, actually a lot of people do this anyway at the beginning of a flooding season. So what we've done is we've sort of separated this into two distinct steps. One is that to prepare so that you can take action very quickly in the short term. So get the equipment. It takes us actually a long time to procure shovels. In the Red Cross, you've got to put in the procurement notice. It might take you a couple months before you actually get the shovels. So we can do this in advance. We can do this before the season starts or at the beginning of the project. And then when the forecast arrives, we actually need a fairly limited amount of time to in fact, dig the trenches. And so in this case, if you look at the traditional contingency table of what might come out of this, you can see that there's some reputational risk of acting in vain, which does constrain a lot of our actions, but that in fact we can avoid a lot of the housing damage and shelter needs that we would ordinarily have to provide post-flooding if we could do this successfully before a flood. So right now we've been looking at a number of different flood models and different products that could trigger this type of action. And you've heard earlier today from someone who works on this GLOFAST model. So this is a hydrological model that's run globally because we don't have a local hydrological model in this region of northeastern Uganda that we're looking at for this specific action. So this is the model that we're considering to use to trigger actions. We're certainly open, as I mentioned before, to a number of different data products. And actually one of our difficulties is to navigate the number of products that are being put available at the global scale. So this is a GLOFAST forecast that we've been looking at. This is a 14-day lead time. And in blue, I've put here dates of observed flooding in Uganda. So you can see that there is some sort of agreement. So we can calibrate this. There are very few river gauges in the region. There is a correlation that isn't too bad, but in the place that we're looking at, we have one river gauge that's somewhat downstream. So I have an idea that this model is probably not too bad at actually modeling river levels, and so the real question is, can we set a threshold of the forecast that would allow us to take action and prevent a lot of these disasters? So, for example, if we set a fairly low threshold, you can see that we're taking action in red. I've put what I'm calling the action lifetime, so that if the trenches are active for, say, a few months, you can see that we'll cover a lot of the peak flows. And so in this particular case, if you put a fairly low threshold, which is something that the team was talking about, you're triggering the digging of trenches almost every year prior to the peak flooding. So this is one of the ways that we're looking at applying this. A different action would be to distribute water treatment tablets. And so this has a different property because it is more possible to act in vain if you're distributing water treatment tablets because they'll be used up. So if you do distribute tablets and then people use them up and then there was no flood during that period of time, you've essentially acted in vain. So in this case, we've split it up so that you would procure the materials ahead of time, distribute them at the time of the forecast, And obviously the target is to reduce the disease burden. This is the place that suffers from cholera and a number of waterborne diseases. So this is a 3-day forecast. It requires a little bit less time to distribute these tablets. And you can see that people were talking about putting the threshold a little bit higher, and that we could in fact have reduced a number of the disasters that we have observed in the region in the past. So right now we're working with the team to start estimating what do we need to know in order to make an informed decision about these standard operating procedures. How do we estimate these uncertainties given the limited data sets? And then how can we go forward and actually start triggering some of these actions? So obviously I've mentioned here the number of different pieces to consider: the lead time of the forecast, the possible actions, how much funding we can possibly spend on this, how many different actions we'd like to select a threshold for, how often we're willing to act in vain, and here it's often hard to quantify this in dollars. The reputational risk is sometimes the bigger constraint here. The cost of acting and acting in vain, how often we want to take worthy action, and then the losses that we're trying to avoid. So where can we get the biggest impact with some of these early actions? So to answer the question that we're being asked, we're starting to try to work with the hydrological community in more depth in this region. And in the end, the answer is going to often be up to the disaster managers themselves, who are going to be able to weigh some of these non-commensurate parameters and say, yes, I feel good about this threshold, this is the thing we're going to move forward with. And I hope that in a few years we'll be able to show that we have systematically acted on some of these forecasts and be able to show actually what some of these avoided losses could have been. So I'd be happy to take questions and feedback, as this is a pilot where we are always welcoming ideas and suggestions.
Thank you very much, Erin, and it's very nice to get these insights from the humanitarian community about the work that we're doing. Are there any questions from the floor? Yes.
Normally, so I think based on what you showed, normally there's also a very political component to deciding when to give money, and now you're taking that partially out by setting a priori conditions. How much politics is involved in setting the conditions?
Great question. I think because it's so new, we've encountered relatively little. One of the things that we have are trying to be clear about is that we do want to set these conditions based on pure model output. And so that no one at the time of issuing the forecast feels the burden of saying, do I put it slightly above or slightly above that, below that threshold? So I think that's where things could become quite political in the future, and we're trying to anticipate that. But so far, I think people right now are sort of thinking of this as an experiment, and you're right that some of those post-disaster political questions have not been raised.
Any more questions? Yeah.
Well, among a variety of actions that you may take, what kind of actions in particular are more benefited by, putting the money just in advance, just like before the flooding comes? Because I thought that some of the actions that maybe you can do it in advance, like far in advance.
Yeah, it's a great question. When it comes to the actions, one of the things that we have noticed is that there are some things that should probably just be done anyway, given the base level of flood risk, but are not being done due to, obviously, competing priorities for limited funding. So some of the things that we will be funding are probably some of those really big bang for your buck type actions, like, rehabilitating a water point. It costs very little. You're going to get a huge return on investment during the time of the flooding when people have clean water to drink. And so some of that return on investment is almost false because we should have done it anyway. And you didn't really need the forecast to trigger that, but in fact, the forecast allowed us to repurpose funding and to allocate funding because the risk had risen so high. In terms of which actions get the biggest return on investment, it's sometimes hard to quantify because if you're avoiding the collapse of homes, it's hard to compare that to avoiding malaria, for example. And so some of these things are really not commensurate. So yeah, I think that would be, yeah.
Okay, thank you very much. Thank you.